Sticking with me, this is the inauguration from the United States in San Diego. So I'm going to start here. So let's share the screen here. Yeah, it's on the TV here. So. Okay, if you're sticking with me here, I'll try to put the subtitles on. If it looks like he doesn't have the subtitles on this video here, this is Donald Trump's inaugural address for the President of the United States, 47th president here, and former 45th president, preceding Joseph Biden here. So, yeah, that is Donald Trump's commitment to America. These remedial changes to change. What we see and endure here in America. So technically, some people don't like them. Some people, might be doing yard work at the same time in the inaugural address. But the thing to remind yourself here is, this is the person who decides our future, who decides this whole area's future, basically. The reality of someone's choice, or the reality of assortment, maybe happiness, pursuit of freedom, the Fifth, the Ninth Amendment. They're all up for stakes here when it goes down to that collateral of humanity. So it's almost a bargaining chip agreement. This presidential inauguration holds, dear to the country as a whole here. Is to going back into what Donald Trump was saying here. There's Elon upstairs. There's a crowd of people. Yeah. Okay, so there's the inauguration. He's kind of going off there. Maybe ending soon. So, um, particularly, you can see, a lot of people are there. There's Jeff Bezos. There's obviously JD Vance is there. Some other commentaries from Fox News. There, Musk's there. I'm sure there's plenty of people there. So, if you can get my last video, we're in the midst of the fires in LA, so we might as well stop there. Kind of look at the LA fire here situation. These are the LA fires, and these are what's stopping them right now, which is debris or the incident fire here. So if you didn't watch my last video about the fires and carbon hydrogen oxide, basically deviating, the idea of like a diamond in the water and freezing the temperature, like, my AQ cast the indiety of the oxygen, hydrogen in the water. So basically, I took it upon myself to take water here, which is, water, and then temper it. It's in, let's see, in a hydrobus of just of a marble with an acrylic cup. Which can create a simultaneous fog, basically. And the stratosphere built of oxygen and just pure hydrogen. So all you would need to do is, have basically a piece of coal. That's all you would need, basically, to put out a fire. So take the coal, for example. It could be a burning mess. It could be compressed coal. It could be wood charcoal, coal cubed wood. But take this marble, for example, kind of like a compressed piece of coal, but it's a different diagrammic metal or composited, like silicon or the blue metals or the silicon itself, right? Aluminum is kind of like similar. But the thing is, it smolders. You have the MPG, and then you have the remnant of the focal molecule there, like an H2O. It's diiodide, right? So basically, you take the alleviate of the oxygen and the hydrogen, basically, and you parallel the assortment. So you can't have one hydrogen bond attached to the other hydrogen bond. The oxygen will escape, basically, the underask or underdressed under F's function within the potential of the hydrogen under the stratosphere, which is the dirt in the situation, which is frozen from porous substrate, or within the containment of let's say 5 atoms are attached to just one particular channel. It's like a Cl bond in the human brain, right? Or biology or biological figure, so to speak, with the air. It just kind of attaches, and it just kind of shakes, basically shakes. It doesn't do much, and then you can feel the assorted carbon underneath the channel, because it's kind of like vibrating on top, right? You can only vibrate it in certain motions, basically. So you take the substrate, even though it's channel locked, right? So the air oxygen is a big circle. It's a circle, but it's a triangle at the same time. So it's the same way in the sky as in the ground, but it's more focused. It's foci, right? So take the potential of one diameter, one pentameter here, and then you can multiply it by the function of like fluorine, right? Like which is like the per cost of water or aqua, right? In this particular setting, basically the aqua remains OO in the middle between the per crust or the top crust and then the bottom. So basically, kind of like a Boole mass statement. So you go instead of starting at 3 or 4 or 1 or 2, you start at 5 or 6 because it's a natural algorithm. So it starts at 0, 0, and then goes to 5, 6, 7, 8. Because the pentameter of an electron is only covalent to hydrogen in the substrate. So basically, the hydrogen substrate becomes something like a distilled liquid. So like when oxygen turns distilled, it usually turns into like something like ethanol. Gasoline is emitted or ethanol is emitted by like feces or diametric metals, basically, things that are elongated, because the magnesium chains are like that. These are attached to carbon chains, basically. So why is it so difficult? It's because we have nitrogen belts here. So say like take the LA fire. So you have like a 3.4 nitrogen loop in the Patur sewer of the channel locked plate. So it's kind of like the scenario of like something you get in China or something like you get in Kentucky, right? Same thing that the OFAC had issues with before they were able to complete contracts for like the Middle East or something like that. So basically, it's built from like a diametric system, right? So it goes through like amplitude and then focused ohms and then a setting of like volts, right? So the settings aren't what they seem to be like, kind of like volumes per cost, like measures. They have a little bit to do with trade agreements, right? But the reality is the pentameters, nevertheless. So basically, if you take the multiplication by like effort work versus the distribution, right? You have something that's somewhat similar, right? The distribution there is not a cost per value per unit; it's per stratus unit per average, right? So instead of a per average unit, you have something like a temperate conchal or temperate like focus, right? So like say seashell is a temperate. It is a spiral not like any other spiral, right? But it is the same type of spiral. So it is a binocostal, binofocal spiral, right? So it has to do with asymptotal literal sums. So that means it's zero staked into something that is like, a remainder of a derivative. So that constant, now it's constant, is an average sum of the z squared sum. So the basic sum there is like, how the focus of carbon would work if it was free-flowing, like the hydrogen and oxygen concept. But in this concept, since it's a human being, it would go H2O, right? H2O. So the beneficial thing there would be like, it would be spiraling and it would be replicating, self-replicating over and over time, right? So just kind of like the atoms we're talking about. So that's what that is right there. So we'll take a hiatus there and we'll go back to the meeting of the president. Oh, it looks like it's over. So that was the election. That was the value of the president right here. And then say, oh, actually, it's right here. It's going on still. But say, you wanted to put the fire out in LA, and all you had was like a single diamond from a Geneva watch. And you're like, well, what do I do right now? I'm like Meatwad from Aqua Teen Hunger Force. I'm going to die if all the rest of the 350 billion houses burn down somehow in California, whatever. Could you take the marble and hypothetically, just pool the water? Put it on there. Well, think about the decentral properties of the acid in the marble, right? Or think about the decentral properties in the marble itself, the glass, right? It's a silicon base, it's like sand, right? But it's glass, right? So basically, take the sand and put it in there, right? But because it would be silicatic, so you would have thermal properties, and then you would have a biofocus or focus, right? In this instance, of two, parts per, like, so many. So the sand isn't like a bio part; it's a huge amount. Sand isn't counted as like a distributed unit. It's a indistributed unit. It's made that way. So take the sand for example. I mean, you might have air bubbles trapped in the orbit. But sand will just basically it will act and suit as a sonic boom, basically. So would dirt do the same thing? I literally don't know the answer to that. Would dirt do the same thing? Would dust do the same thing? Dust probably not. It's a particulate like magnesium, so it has a chain that reacts both ways. So hydrogen and oxygen react both ways. And just like this, there's the atmospheric like marble in here. That's like an atom, right? It vibrates, it makes the vibrations. When it clicks, maybe there's a positive reaction right there, right? And there's the negative force. So take the marble here. What you're seeing is the marble, right? But the color of the marble also matters. So the silicon purpose here, this is theoretical. This was proposed a long time ago, but it was never accepted. A principle of Liviant math, right? So the principle here is like if the color is different, right? But it is different. Let the fucker do his thing with it. Which he's being a fucker right now. So basically, take the marble for example. If you were to put dirt on there, right, it would be as like like great. It would be as like as what like disodium is, right? Like it's a pool of like disodium. You just digest, right? Like it's not because you'd be poisoned, right? You'd be dead if you ingest sodium. So the point is, right? The reality of like this water, the marble, they're all percussed like measures, right? The individual reality there. These being a fucker, can you hear me? Is a reality by itself. So take the marble for example, right? You have the marble here. You have the individual gram of what is it called? The literal gram of the marble. No, the gram of the ice surrounding encapsulating the marble, right? So basically you have there is an individual freshness. No H2O. You have H2O, right? You have H2O, right? So basically, the marble, the connected, tissue to the marble. In this example, it's H2O and the hydrobus, which is the bacteria chain in this, and the magnesium, which is like the ions in some instances as well. So take, for example, that, and then you have a permafrost of any conditional water that has escaped, not escaped. It might be the salt in the water, which is like kind of salt compound, or a disodium selective ion, right, which is splitting the oxygen and the hydrogen together, and it's not coming together. This is hydrobus, and then the hydrobus solution is also contaminated, or it has an inner contaminant, right, which is linking two bonds together, right. So you just basically have to link these covalent bonds together, right? But you have to work not to burn them off, but create a simultaneous hydrobus, right? So the solution there is not exactly hydrobus, hydrogen, right? It's not hydrobus, oxygen, right? People might say it's oxygen, right? And again, we go back to that O thing, right? Like there's a chain reaction with O3, right? There's not a chain reaction with O3. Well, why don't you make some O3 there? And then you vibrate like a chimney, right? You don't just stand in the earth and make the earth spin at all times, or else it would be multiple spikes and there would be like an earthquake, right? Like if you drilled into multiple holes in that stratosphere right there, you would basically have that, right? Like same for a tank. If you kept on tapping all the tanks in the world, right? You basically have shaken earth, right? So the principle there is, once the marble has a permafrost like this, it's going to be cloudy because the ice is starting to break up, right? It's breaking up like the stratosphere breaks up, like in like the meteorite comet, because they don't have oxygen there. It's extremely cold. It's solid cold, right? So it's beyond cold. It's like a Kelvin, right? So the permafrost there is a solution itself, right? So it has a carbon hydrogen base, but it's unlike any human interaction or experience there, right? So you have the hydrogen and then the carbon. which is another chain in that reaction between the meteor belts. But if you're not aware what that is, or what another thing is, it's a reality, right? So it's a biofocus diminution of like what's the transfer wave to another transfer wave. So the spectrum doesn't end with yellow. It doesn't absorb yellow. Yellow leads to orange, and that's it basically turns into like a photic cell. In mathematics and biology, we don't really have a science for the focal of like these chains, like a magnesium chain, like you replicate COH over and over again, right? But the intensement, or like hydrogen base, we don't really have a whole system for that. We don't have a whole system for carbon. We don't have a whole system for something like poop. Like for poison poop, we don't have whole systems for that. Like aqua, water, those are demised technologies. So like they base themselves on the Remnir of like light frequencies, right? So to speak. But when you take the marble and you case it in water, right, it's different than the material, right? So take the focus of like a marble surrounded by something, like you're looking into the glass marble, you might see it a different color, right? Especially if there's color stream in there. So that is another interesting concept. So the reality there is, focused amounts of like, cell death in a way, right? I mean, like, so fire is like cell death, like the hydrogen is if you put it into an atom of oxygen, right? So that's particularly, a different kind of a diffusion, right? Like biological processes and that clockwork, they don't really exist. They're like a hydrogen to oxygen. We don't really have hydrogen to oxygen, figures, right? We have like, plant eaters, which like eat like, plants, right? And then they breathe out still carbon dioxide because the photosynthesis and the oxygen turns into CO2 from a substrate of like what is a focus, a split in water, right, or a part of water, or an instrument of water, so transfer of water basically. That particularly is like travel versus velocity and oxidation plus material accumulation, voltage, all these little things, and it builds up over time. So the part of oxygen there becomes like a disodium over time, and then it becomes immunorescent. So basically, it's like a radioactive wave. It kind of zooms out, zooms out, zooms out, zooms out. But it is at the opposite, right? So does it the opposite? We can see this. So if you were to take soil, again, if you were to take soil and put it on this cup, what would happen? So let me try to find some soil. So it works kind of like, the way pool cleaner would work, right? Like you would have disodium, you have a deselective property within the function of so that's like, it's dry matter, right? Dry brush, right? That's anything that is in the potential to cause voltage gain, which is based on carbon, biological focus, oxygen, hydrogen, and then the sulfur compound do whatever it is. Okay, so I found some dirt here. I thought it was sand, but it's dirt. It's kind of like almost an emulsient dirt / sand. You're like, how do I get this? You get this from a burned TEPCO coating. So basically, I got some on my computer here, but this is what it basically looks like here. So I have some sand here. Fucker started again, right? So, okay. So basically, I'm going to take the sand and put it on the water. So you can see the cup of water. I'm putting it in here. So I'll take the water, which is frozen still. As you can see, it's frozen. So take some dirt, put it in there. Now there's water and dirt. It's subcutaneous, kind of like the culture is leaching. The soil is leaching into the properties of the actual cup here, right? So some of it sticks to the permafrosted ice there. Some of it leaches out, right? So what you there have is hard hydrogen separated by a substrate of oxygen that's charged with positive volts there, and then a negative charge, which is like an ion base, based in hydrogen right there. So that basically, that substrate, and if you can actually see it there, make sure you can see it, is a substrate of hydrogen voltage amp gain, right? And it's not just voltage and hydrogen gain, because you can see the oxygen bubble right there. Can you see the oxygen bubble? Maybe, maybe not. But the reality is now it's semi-focused, right? So the molecular structure in this cup here is not just reversed into hydrogen and oxygen, right? The reality, it turns into a totally different molecule, right? So basically, the hydrogen and oxygen sits there, and it even saturates into, a diminution. So what does that mean? So the negative focused ion particles in this calculation of the material soil that we found, right? It separates into one hard section and another hard section, like the hypothesis. So the hypothesis is the root sum, right? So take the Faraday coat, or take the Faraday bag we had, for example, right? The example of the Faraday bag basically said one part is one side and the other part is the other, right? So without the fold, you can't have a manifest. Without the manifest, you aren't able to enclose the reactor or reaction, right? So what we have there is a bunch of volts that don't go anywhere, right? I mean, we can agree it's kind of a volume. It has a pentameter, and then it has more than one use, or it has more than one use, basically. Okay, so the pentameter there basically counts just like the Faraday cage. Electrons, balance, and they resort to greater than a sum of the even set of electrons in that function. So how does that become? Because the rays are different on different functions. So take, for example, the electron belt of 0, and it's a cross chain, so it doesn't have a network, right, of chains, or it doesn't have a pentameter, right? So basically, the pentameter there is free-flowing electrons, right? Kind of like the hydrogen base in something that is like radioactive. So it has a frequency, it leaks, it emits radiation, it does certain things, right? So the pentameter is equal to the force of the value. And there's, again, one figure there, which is, the function, the force, or the particulars of the matter. So when you look at the solution and you see it's in 2 spots or 2 decimals, that means there's some sort of electronic current going through it. But why is there a pentameter when there's, 2 of things? So does that sit like sulfate? Yeah, it sits like sulfate, basically, right? So take sulfate. Let's say it's a nuclear sulfate, and it's represented as 1B. So the function there isn't like, the hypothesis of that function, of the electron transfer being on a data, like, data cable, right? The illusionary cable isn't separated into numbers and then, a constant. Right? In this case, it is B, as it is for the function of the value. Was one function of value. So take the beta wave again. So the volume of the beta wave isn't a set stone thing, right? The volume of the beta wave really, it's rapid decurrent. So basically, from that free flowing electron to the start, it becomes a negative function in value, right? So that value becomes, like a disodium or din selected, right? So it doesn't mean, it decomposes like as a radioactive corpse, like it can go into a nuclear generator and uh, degenerate like a radioscopic material, right? It doesn't do that, right? But it does take the Perkos electron, right, in that situation, and then it turns into a value, right? That's a C. Basically, that value is constant. Like that constant is a frequency of volume. So that volume and that really just one way, right? Just one thing is like a constant, like in mathematics, right? It has a function, a sum, and the remainder. So basically, when you look at the remainders and you say like, this is a repeating number, this is not a repeating number, it has spaces in it, and some of it's like together, some of it's not. And then you're like, you'll take, for example, the laser beam. We have a laser beam here. I mean, would that be a distribution error? How would else you test this equipment? Or, what other properties does this have? I mean, is it a reference number? Is it a, beta wave itself? Is it a distribution of like a volume versus effort, like we were looking at before, the discussion of like decaying matter, right? Properties of decaying matter. The value there is is a value of focus, right? So it's a value of like focus, kind of like the sulfur is basically. So the volume is, like an electron belt, right? But it's not that simple. So take, for example, the substrate here. It becomes clumped over time. It doesn't just decentralize, kind of in one transfer wave and become like, transfer protocol, right? It becomes, like, or ATP, like a human body. It becomes something more. It becomes, a permafrost itself. It separates. It transfers those waves like a sulfate would. It becomes clumped, like kind of like how the country is formed, or how the continents formed in the on the Earth's crust, right? So basically, one volume versus the other, and then what is the difference between the substrate in the Earth and out of the Earth? Because it's nuclear. One is nuclear and one is not nuclear. One is biofocused and one is not, right? So is it poison? I mean, it is poison. So like, think of like if you stick your hand in a gallon of oil, right? Your hand's going to get black, right? That's one good way of putting it. So even if it's thin oil, it's thin water oil, your hand's still going to get black, right? Yeah. Even if it was in the invincible itis cup, the transfer protocols, it technically could it get black? I think possibly it could get black, right? Even with oxygen, could it get black? I believe so. So the hypothesis there is one data transfer, or one transfer of the electrons from oxygen to the hydrogen, are basically like electrons that are like helic, like structure of an atom. And you're like, oh, so the electrons could form free-flowing like invisible atoms. Well, the distribution there says like, one is like rotating one way, one is doing another. They're all organized somehow. And then the reality of, one constant is one value or one volume. And then the instance of, the volume versus like, the water volt. And this distribution, right, is basically, the same. So the similar structure there is, like one volume, 1 volt, basically. So take the distribution there and take the, constant, and it becomes, more of a necessitated, volume and structure, basically. And then you ask yourself, like, why is the volume, one distribution, like electron away? What I'm saying? Like, why is, the distribution so, slow? Why would the transfer be, easy to, connect, right? Why would the distribution be, why would the distribution be, different, right? So take for example, you were to take a laser beam and shoot it at the dirt on the permafrost of the soil there. It reflects, it refracts. It basically directs like an electron protocol transfer right there, right? It's mimicking the transfer because it's a delta wave in the sense that's right. So what if it is biofocus? So in this instance, it's low and dim, right? So it's a self-starting as fuel. So basically, you direct the atmosphere in the situation. You drop the T, right, so to speak, and then you kind of function through, right? It's like a delta wave built within, two particles of a delta wave, right? So the particulates of this value are kind of like a transfer itself, right? The transfer can basically, hypothesize like a small amount versus a greater amount. Kind of like the oxygen escaping, right? And the laser beam, is a trapeze, type of like, hydrogen, right? So it's hydrogen and oxygen shining through the flow, but speeds it up. So it's a hypothetical type of thing, right? So the transfer right there is like a delta wave, right? The function is volume versus weight over an average of like something like speed, right? So it's all speed. This is all substrate matter, right? One is perfectly clean, one is not. And the H2O is technically a free-flowing form of, atmospheric pressure, basically. So basically, what we have from the situation of looking at, the water here, basically the marble has dropped through the atmospheric, pressure of the, ice here. So now we have the marble that's on the bottom and the substrate, and if you look at it, it's collapsed basically. So basically, the substrate in there has collapsed around it. The hydrogen has now pulled around the structure of the ice here, which was enclosed and made a decree from the electrons in the marble, which were hard. So if you take a marble, you smash it on the ground in a regular day, right? It's hydrogen, say, it has carbon, it has oxygen in it to build its mass, right? It's selective. The marble is technically carbon, right? So basically it's smashed, but it doesn't do anything. It doesn't break into little pieces. Maybe it's not cold enough. According to some scientists, the Kelvin scale just sheds light that when you smash something on the Kelvin scale, it breaks, right? Even a diamond breaks. But that's not entirely true. As you can see, the substrate here has an oxygen bubble in it. So it's not like you need to smash it to show something like it is, right? We tested the laser beam. Is a laser beam a lot more significant than the smash idea? To break it down and look at the substrate, it is basically showing, there's hydrogen still in this substrate and it's charged as a positive ion, positive electrons, and then a positive variance and a valence. Yeah, because it's being discharged. It's kind of like the disodium process we have. So take the metal here. It's rich in magnesium because it has this chain reaction going on, right? Because it has a carbon, a hydrogen, an oxygen, and the atoms are free-flowing electrons, right? But in this pool, they have a contaminator, or a pentameter, and they have like a sort of container that is looped, but it's not functionable yet, right? Kind of like the beta waves, like going through the alpha waves. I mean, once they do that, they decay, right? The radiations take sex. Not exactly. So when you take the beta waves, for example, and we were talking about this before, it's just at 1-0, and then you're like, oh, the remainders are balanced. Well, not exactly, right? Again, because we were talking about the simplest thing yesterday about starting with 1, right? So all atom chains start with 1, like the hydrogen and then the hydrogen base, things. Like nitrogen, for example, is just like a variant wave of beta. Nitrogen, I would say, like is the closest substrate to an alpha wave in beta. So that means it is prefix. So basically, 1 gram might equal 1 nitrogen base in 1 volume, because the charge is an electron that is balanced in between a median of the charges, and then the volume, which is, in this case, fuel, and then the merger of the particle electrons, which are based on hydrogen and oxygen. I would say, those basically are concentrical forces right there. Those are basically what are tracking, 1 or 2 things together, but not 3 things, basically, or 4 things in that order. So basically, you have a superous force, basically collects, not like a magnet coil would, but not exactly just because it's a magnet. So you have the force, you have the volume, and then you have, whatever matter it is, the substrate. So basically, it's a repeating sum that is, distributing its volume and weight outside. Kind of like, what a debit card would do. So take a debit card, the volume might be considered differential, right? It might be considered based on a zero sum. But a chip of a credit card or debit card might do something else. But what if it was, if you had a smaller striping, unit for a debit card, right? Would it do something else? Well, it would do in our, we neither one, not just because we don't have it. It means that we get the opposite. Smaller means slower in this compound or compound function, basically. So in particulars, you have 1 of something, 1 distribution unit per distribution of, effort per volume, and then something like a volt. So anybody can decide a volt. It's more of a product of containment, a product of resolution, basically, right?
Right. Yeah, that's true.
That's it. So basically, with this volt, you see what I'm saying? This volt basically is like a beta wave here. That's it. This volt is like a beta wave. So basically, that means it has like a proton balance, right? That's it.
So that's what you guys do.
So the volt here, like the variance ion, right,
Okay.
transfers
Okay, you too. Thanks.
to a variance
No, I
ion.
was just going to say you have a great day too, and thank you.
But it particularly isn't normal, right? So we have the zero variance, which is represented in, a matter, which is a substrate. Kind of like the variance, balance, right? So this is, one focus. We have the substrate of the marble. It's now become something you can look at, like something is blocking it. So say there's a clump of something that doesn't, that's it. You have the volume, the weight. You have the volume, the weight, and the distribution right there, right? So So the volume is the mass, but the oxygen is still inside the mass. And then what we have there, again, is the hydrogen. So it could be a fuel. So in this nitrogen-based, helium or nitrogen-rich environment, you might have a volume that is distributed in the two parts of the transfer, right? Like we were talking about yesterday. The distribution there is, the effort of the oxygen, which is the electrons, in that belt we were talking about yesterday, free flowing through the hydrogen and the hydrobus. So instead of the opposite happening, where it's a free flowing liquid basically, and the chain is just kind of going over and over and over again, and there's some simultaneous substrate where the hydrogen and oxygen go together, right, and build that bond with the other covalent bonds, right. So there, the basic building blocks there are the distributions of the effort of that. So basically, when it's frozen, it does. Let's look at this. The distribution there is the reality of the oxygen trying to escape. Well, I mean, look at it. I mean, so the marble is the hardest part of this substrate, right? The marble is technically one of the hardest substrates, but there's the color in the marble. And, well, yeah, there's color in the marble, right? But the substrate is also uneven because there's a balance on top. The permafrost, the soil has collected on the top as well, these foreign contaminants. And there's the contaminant on the bottom, which is the sand, which hasn't been counted. It's an unknown, right? And the selective property, it's like a silicon base that is also carbon rich, and it is full of different various materials. Well, I accumulated most of them. If it has a gram-like structure, it attracts to gram-like structure. It's probably a high amount of gram, right? Like a high amount of positive reactive energy, right? But before, when it was on the ground, it was a gram positive or neutral or negative, right? It wouldn't have been any of those things, right? Because it would have been in the substrate of, a resurrected carbon chain. It would be part of a focused carbon chain, right? So basically, you have the H2O, which is in the liquid solution here. It's no longer just H2O. There's a bunch of molecules in there. So take the volume of that weight, and then you expect does it go a certain way? Does it crack the atmosphere of the substrate? Well, it kind of does, because the bubbles can go one way or the other, but it kind of doesn't, because they're always meant to go that way, right? So the substrate there is kind of like sulfate, is like to sulfur, or sulfide is to a hydrogen and oxygen solution. Because again, it's like encapsulating it. Like the oxygen encapsulates the sulfite electrons, and then the hydrogen encapsulates the oxygen by splitting those two covalent bonds to another two covalent bonds of hydrogen, right? And that purpose, it creates a covalent bond which is attached to oxygen, two covalent bonds, and then it kind of roams in this effort of the electrons flowing. And then there's a few ways in molecules that do different things, right? Kind of like the ones we were talking about before, the blue group, between that pentameter of distribution of one element being multiple elements, right? Distribution here is also a wavelength here. So basically, the wavelength isn't one chain or a molecule in this instance, right? Because H2O is a molecule, right? Correct. So the distribution there, is something maybe is gram positive if it's encapsulated inside of the gram, right? Or the distribution there is bifocus. So is it both? It is both from looking at it. So it means that there's one, more than one molecule in the distribution. There's one more value in the distribution. So it's kind of like natural statistics. So you have the H2O solution, it encapsulates the oxygen, has the bubble. It means there's a foreign contaminant if there's still hydrogen and oxygen on the outside electron balance, because it's covalent. So I'm going to end the progress of this video here. So thanks for watching.